let's look at adding and subtracting surds. Now, the key thing to remember is it's no different to what you do in algebra. Okay, so in algebra, if I go that 2x plus 3x is 5x, it's the same as going 2 root 5 plus 3 root 5 is 5 lots of root 5. So I've got 2 x's, I add another 3 x's, I've got 5 x's. I've got 2 root 5s, I add 3 root 5s, I've got 5 root 5. That's the key point to remember. So there's a bunch of rules there that you can try to remember, but you don't really need to, because it all comes down to logic and remembering that just like algebra, like surds can be added and subtracted. If they're not like surds, you can't do it. So I can't add x and y, for example. So if we look at my rules here, I've got a root c plus b root c. So you can see here that root c is the same. So therefore, all I have to do is add a and b and put my root c. Similarly, a root c minus b root c, the root c's are the same, so I can just subtract my a minus b and put the root c. I can't add or subtract unlike surds though. So if I look at the examples down the bottom, I've got 3 root 2 plus 5 root 2. So I have my root 2 and root 2. So I know I can add here. So I just go 3 plus 5 is 8 and write the root 2. Similarly, in the next one, I have both are root 7s. So I can go 10 minus 3 is 7 and then just put the root 7. Next, I have 5 root 3 plus 6 root 3. Always take the sign in front. Okay, but the other surd, the root 5, doesn't match. So when I do this, I do my root 3s, 5 lots of root 3 plus 6 lots of root 3 is 11 lots of root 3, and then I've just got plus my square root of 5. Looking at some more examples, highlight the things that are the same. 8 root 6 minus root 6, root 2 minus 2 root 2. So let's start with the root 6's. I've got 8 root 6's minus 1 root 6, which gives me 7 root 6. Root 2 minus 2 root 2. So 1 minus 2 is a negative 1 root 2, but I don't write the 1. So just like in algebra, you don't write 1x. Okay? In the next one, my surds aren't the same. Square root of 12, square root of 27. I can't do it. But I can think to myself, can I simplify the surds? So off to the side, square root of 12 is equal to the square root of 4 times 3, which is the square root of 4 times the square root of 3, which is 2 root 3. Square root of 27 is equal to square root of 9 times 3, which is equal to square root of 9 times the square root of 3, which is 3 root 3. Okay, I'm going to put a line down here so it doesn't get confusing. So if I come back here, I've got 5 times root 12. And my root 12 is equal to 2 root 3. Okay, so I've got 5 lots of 2 root 3. Then I go minus, and then I've got my square root of 27, which is 3 root 3. So I go minus 3 root 3. So 5 times by 2 is 10 root 3 minus 3 root 3. I can now subtract because I've got square root of 3's, both of them. So 10 minus 3 is 7 root 3. Okay, next one, 2 root 18 plus 4 root 27. Again, off to the side. Square root of 18 is equal to square root of 9 times 2. So square root of 9 times the square root of 2, which is 3 root 2. Square root of 27 is equal to the square root of 9 times 3. So square root of 9 times the square root of 3, which is 3 root 3. Okay, and I'm going to put a line down there. Okay, so come back to my problem. I've got 2 lots of the square root of 18, and the square root of 18 is 3 root 2. So I'm going to do 2 lots of 3 root 2, plus in the middle, 4 lots of the square root of 27, and the square root of 27 is 3 root 3. So 3 root 3 goes there. 2 times 3 is 6 root 2, plus 4 times 3 is 12 root 3. Those surds aren't the same, so I can't do any more. Last lot, square root of 8 minus the square root of 2. I can simplify the square root of 8. So square root of 8 is going to be the square root of 4 times 2, which is square root of 4 times the square root of 2, which is 2 root 2. So I've got 2 root 2 minus root 2. 2 minus 1 is 1, so it leaves me with just 1 root 2. Next one, 108. Nice big number to try and work out. The way I do this is I go, okay, well, what's my perfect square? My first one, it's 4. So if I go 108 divided by 4, I get 27. I go, oh, okay, well, 27 is a perfect square as well. So I'm now going to try and divide by something bigger. So I go 108 divided by, and I might go to 9. And it's 12. Oh, 12 is a perfect square. Okay, so we're going to go bigger again. So I'm going to go 108 divided by 16. Doesn't work. 108 divided by 25. Doesn't work. 108 divided by 36. Oh, it's 3. Okay, so I've got my smallest perfect, or my largest perfect square. So square root of 108 is equal to the square root of 36 times 3, which is a square root of 36 times the square root of 3, which is 6 root 3. Square root of 25, 75, went for the answer straight off. Square root of 75 is equal to square root of 25 times 3. So square root of 25 times the square root of 3, which is 5 root 3. So I come back here and I replace. So 6 root 3 plus 5 root 3. 6 plus 5 is 11 root 3. Now, if you didn't realise that you had a larger perfect square, okay, you do have another option. So if, for example, you went 108 and you went, okay, 108 can be divided by 4. So you went square root of 4 times 27, which is a square root of 4 times the square root of 27, which is 2 root 27. You have to realise that that square root of 27 can be divided by 9. So you have to go again. So that's equal to 2 times the square root of 9 times 3, which is 2, which is 2. So I've got 2 times by a square root of 9 times the square root of 3, which is 2 times by 3 root 3, which is 6 root 3. Okay, which equals what I had up there. Okay, so if you can't do it straight off, take 2 turns. It's okay to take multiple turns to get, but you have to realise when you've still got a number that can be reduced smaller. Okay, let's look at the last one. Square root of 45. So square root of 45, thinking about what goes into that, 9 5s are 45. So square root of 9 times 5, which is square root of 9 times the square root of 5, which is 3 root 5. Square root of 20, we've done that a few times. Square root of 4 times 5, which is square root of 4 times the square root of 5, which is 2 root 5. Come back to my problem. I've got 6 times root 45, which is 3 root 5, plus 3 times the square root of 20, which is 2 root 5. 6 times 3 is 18 root 5. 3 times 2 is 6 root 5. 18 plus 6 is 24 root 5. And I'm done. So just remember that key point, that surds can only be added or subtracted when the base numbers are the same. So when you have roots that are the same.